Um, I was doing something. Could you repeat that, please?
Why do you think special relativity? What evidence is there that makes special relativity more likely to be true than aether theory?
Experimental evidence.
Like what?
Did you say ether theory?
Yes,
Yeah,
I
Yeah,
did.
ether.
Aether. Yeah.
Yes, you did.
Yeah, like what? What's
We got some real
experimental?
geniuses here, X. The
Like
Michelson
what?
Morley.
I don't do that.
Michelson Morley, dude. Michelson Morley.
Okay, yeah.
Wait,
So
wait,
you're
wait,
gonna
wait, wait, wait.
appeal to Michelson Morley, but
No,
you're
let's
gonna
discuss
ignore
Michelson Morley.
all of the experiments done on
No, no, we
Mount
can agree with
Wilson.
Michelson Morley. I'm
Sure.
so confused what you're saying. In
Well,
special
you
relativity,
asked
there's
me.
wait. Let me look. In special relativity, do you know what Lorentz transformations are?
Sure. You asked me
No, I'm
why
gonna
I
explain to you
accept.
because
Let
yeah,
me
you're
finish a
completely confused.
sentence, or I'm going to break off.
No, you didn't. Yeah,
You need to allow me
Yeah,
to
you're gonna
finish
run.
sentences.
everyone cut me off. This is
You need
ridiculous.
to allow me to finish sentences.
You
You
got
already
You asked
talking.
me. Just a minute. Just hold your horses. There will be plenty of time for you to have your
all right. What?
response.
Go ahead.
You asked me why I accept relativity over the aether theory, and the pivotal experiment that refuted the ether was the Michelson Morley.
Right. So let me. You're very confused, right? Because I asked you what about Lorentz transformations?
No,
When
you asked me why I accept relativity
yeah,
You
over
yeah,
already
the
answered
ether.
that.
so let's discuss Michelson Morley. Why does it disprove eighth theory? Right? Let's
Because it
discuss it. That's
shows
what I'm
a
trying to say.
contradiction. Because it shows a contradiction.
Yeah. So let's see where. So you got to show me the You can't just assert that, right?
Yeah,
So
yeah,
I'll
I
just
know.
show you why it's not. It's very simple. Wait, slow down. Let's just.
I can
Have you
explain
heard of?
it to you. I understand it. I can explain it to you.
Okay.
Right?
Have you?
On the
So do you
ether
understand what
theory,
Lorentz?
on the ether theory, right? The prediction is that on Earth, which is rotating, the interferometer would show a difference between the two different directions. They didn't show a difference, and so therefore the ether theory is refuted. That's how it works.
Yeah, except that
No, no,
only.
no. That's not true at all. Wait.
Yes,
That's
it is.
literally that's
Wait,
false.
let
Wait,
him
That's
finish.
literally the theory. Literally
Let
the
him finish,
no,
theory.
bring
no, no. Again, let's discuss Lorentz transformations. You're not actually discussing the math. And
We're
wait,
discussing the ether theory, not
let's
Lorentz
discuss it. Wait.
transformations.
Why are you?
Yo, can we get a moderator?
You're not. You every time I'm talking about, I'm trying to discuss the ether theory. I'm trying to discuss the math behind what Lorentz did. Right? Lorentz transformations. Lorentz held ether theory, and what Einstein did. So, because you're completely confused, right? Okay. What happened was there was a certain uh ether theory, one that predicted that what you said, right? That the speed of light shouldn't be constant. It turned out the speed of light is constant, right? So
It
what did
had
Lorentz
nothing to
do?
do with the speed of light. You don't understand.
So
It had to
we're
do.
not gonna let him finish.
Listen. So what did Lorentz do, right? Lorentz came revised the ether theory, right? That's why we came up with Lorentz transformations. What did Lorentz do? Lorentz explained why the how to explain the Michelson-Morley experiment in term making it compatible with ether theory. This this is and then Einstein read Lorentz transformations. Well, what did Einstein do? What was actual Einstein's idea? Einstein, because of metaphysical reasons, not because of the experimental, because of the experimental data. You're just wrong about that. It's
I'm.
Lorentz.
What am I wrong
You're
about?
not under. You're just never mind.
But what am I wrong about? You said I was
I just
wrong. What am I
I'm
wrong
explaining to
about?
you again. You're not. Okay, do you even know? Okay, what's the
That's
formula for
fine.
time dilation? What is it? No,
Just
just let's
tell
discuss
me,
it because you really.
what does
What's the
time
formula
what
for
does
time
time
dilation?
dilation have to do with anything? We're talking about the
No,
Michelson-Morley experiment and how it refutes the ether theory. And you're saying, yes, you're right. There have been subsequent attempts to rescue the ether theory after the Michelson-Morley experiment, but they have all failed.
wait. How did wait? I'm
There have been
saying.
other experiments, right, to test those other theories, and
Well, like the
the
Sagnac effect.
relativity relativity has won. Relativity is the winner, and the alternate theories are losers.
That's a really basic view
Look,
on
I'm not.
the
You
history.
pointed out. I'm not sure. All you're saying is that there was one. All I'm saying is this: before Einstein came up with special relativity, there was already an aether theory that was compatible.
Yes.
That
There
was
was an
compatible.
aether theory. Yes, you're right.
That was compatible with Michelson-Morley experiment. Lorentz came up
No.
with it.
No,
No,
the
yes, he did.
Michelson-Morley refutes the aether theory. Michelson-Morley, they thought the aether theory was true. They thought they were going to discover the ether because, that was a hypothesized thing. And they failed. And that failure was one of the greatest failures in the history of science. Because by failing, they showed that what was left was Einstein's theory of special relativity. Right?
Listen,
You understand?
you don't understand the history of what happened. So it's almost pointless to me because you're
You
not.
haven't told me anything.
I literally every time I bring up Lorentz transformations, you're just not getting what I'm saying. Like, am I speaking Chinese? Like, I don't understand what's so confusing. What I'm saying. I'm saying, look,
So go
after
ahead then,
Michelson-Morley,
explain it then.
a guy named Lorentz. Maybe you don't know if you've heard of him. Okay, he came up with the math to explain Michelson-Morley, right? So he actually explained and his theory was compatible with aether. He was an aether theorist. Okay, what did Einstein do? Einstein took Lorentz transformations. All of the math that Einstein did was already in Lorentz. So you're not understanding that. Like,
Yeah,
all
Lorentz
Einstein did.
transformations are still a thing. They're used in
You're
special
not,
relativity. They
yes,
were
of course. That's my
adapted.
point.
Yes.
That's my
But
point.
that doesn't save the ether, dude.
No, you're not understanding.
It doesn't save the ether.
You're not. Listen, just think about what I'm saying very slowly. I'm going to go as slow as possible. Right? Lorentz was an aether theorist. He came up with Lorentz transformations, which you agree with special
Yes,
relativity easy,
yes.
right? Wait, slow.
Yes.
Just let me finish.
I
See, you're not letting
agree.
me finish. Okay,
I'm just agreeing with you. What are you freaking out about? I'm agreeing with you.
because you keep cutting me off. That's why. Just let me finish what I'm saying, and then you could. Okay, Lorentz. The math that he used, right? He was an aether theorist. He explained how to be an aether theorist and use all these Lorentz transformations and be an aether theorist. So it was already before Einstein existed. It was the Michelson-Morley experiment was already compatible with aether theory. All Einstein did, he was on metaphysical reasons. He rejected the aether theory. He had nothing to do with the experimental evidence. You just don't know
Who
what
had
you're
nothing?
talking about.
I'm sorry, I missed part of that. Who had nothing to do with the Michelson-Morley experiments?
Lorentz, that's what Lorentz transformations are, right? So Lorentz realized, okay, how can I explain, like, what's the math? Like, if I accept the Michelson-Morley explanation, how do I explain the math? So he came up with the Lorentz
Yeah,
transformations,
yeah.
right?
And it's been
Okay,
incorporated into
but
special relativity. Yes, I
Lorentz
understand
was,
that. People,
but Lorentz was an aether,
physicists,
Lorentz was an aether theorist,
physicists use Lorentz transformations today, and they do
right?
it
But
under the regime of special relativity.
yeah, but Lorentz was an
Nobody
aether
believes in
theorist.
the ether, dude. Nobody believes in the ether. Nobody believes in it. Well, except for
Okay, well,
crackpots on the internet. But
we're not
other than that,
discussing what people believe.
yes, we
I'm not.
are. Yes, we are. We're discussing that because I said
No, we're discussing
that
the
the
evidence.
Michelson-Morley refuted the ether. And the
No,
fact
you're
that
not.
Conrad Lorenz went and rethought his ideas about this and was able to have Lorentz transformations incorporated into relativity only proves what I said, that the Michelson-Morley experiment refuted the ether.
You're not. You're not understanding anything I said. Look, I'm gonna say something.
So, okay, let me ask you a question. What
Okay.
is the medium for electromagnetic radiation?
Let's just say if I'm an aether theorist. I say the ether. What?
Yeah. Do you have any experimental evidence for this medium?
Yeah, the Sagnac
Sure.
effect. Yeah, the Sagnac
No,
effect.
well, no.
That's not
I mean, I
related
could
to
actually
it at
cite.
all. You have no idea what you're talking about. Again, Ace.
What do you mean? I mean, I could just cite the
Yeah, I
Michelson.
actually do.
Wait. I could just cite the Michelson-Morley experiment. That's because my compensating theory, geez, theory of aether predicts that Michelson-Morley and all this other special relativity. My point is, my theory underdetermines all the
You're
observational.
not
Wait, let me
completing
explain.
the
Let me be clear
sentences.
what I mean. All my aether theory underdetermines all the observational evidence of special relativity. So every evidence for special relativity is evidence for aether theory. So
No,
they're
it's
both
not.
equivalent. It
It's
is.
not. You're wrong. The
I'm not wrong. I'm not right.
Michelson-Morley experiment refutes the ether theory.
You could just saying that, but you're not. Okay,
Yes,
you're not
because you
understanding.
don't listen.
You're not. You're not. Dude,
What am I not
Lorentz.
understanding?
Okay, let me.
You're just spurting
Lorentz.
out. That's all you've been doing for 10 minutes.
Lorentz, after Michelson Morley came up with Lorentz. Lorentz was an aether theorist. You're not. Look, just accept this. Do you
Yes,
accept
I
this fact?
know that. And
Okay, so do you accept
the Lorentz transformation is incorporated into relativity.
Right,
Scientists use it
exactly. That's my
today.
point. That's my point. So it's not
That
like
doesn't no just because it's used does and just because Lorentz was an ether theorist, it doesn't follow that ether is a thing. It's not.
no. The point is, what if the math between aether theory and special relativity are the same? What's okay? Then what?
They're not. What are you talking about?
Okay, what's the
Lorentz
difference?
transformations are spatial transformations. Mike, relativity is more than that. What are you talking about?
I'm not sure. Look, I'm just saying. Look, you're not understanding what I'm saying. This is almost a point because you're not. All Einstein did that was different than Lorentz is he just denied that. The point is the most of the
You're not, dude. You're not even completing your sentences. Try to
I'm
slow
trying to
down and form
I'm trying to explain it to
entire
somebody who's so
sentences
stupid
where
like
you
you.
actually
So
complete
let's
a
just
thought.
Can we get some moderation?
I think all he's trying to say is that the Lorentz thing was the same thing as Einstein's, that he rejected like one part of it, which made it special relativity, right?
right the
So
The
it's
Lorentz
math.
transformation
Lor-
is just a transformation of a coordinate system, right? That's all it is.
no, I'm not sure what you mean by that. Lorentz transformations explain both length contraction, time dilation, which is special relativity, right? So I'm not sure what you're talking about, right? It also has time in it, so I'm not sure what you mean by like you said something that's basic. All right, Einstein uses those equations. For example, I
Okay.
don't know if you know. Do you know
Can
anything like? I mean,
can I
just
ask
let
you a
me.
question? Can I
Can
ask
I
you a
just finish my
question,
sentence?
please?
Can I finish my sentence? Can I finish
You
my sentence?
haven't been able you aren't able to complete a sentence when
I
I
don't
let
care. Okay,
you.
I can't conclude a sentence. All right, just let me finish it. I don't care. All right, look. Do you even know the equation for time dilation? This is it. All right, 1 over the square root of 1 minus v over c squared, right? That's what Lorentz came up with, right? Einstein used it, okay? Only thing is
Yeah.
Einstein, okay, so only difference is that Einstein,
That's not all of relativity. What is relativity? In one simple sort of explain it to me like high schooler sentence. What is relativity?
uh, well, I'll say something like I guess speed, velocity, time are relative to a frame of reference, basically. These things are relative,
It
right?
says that the laws of physics are invariant, right, within an inertial reference frame. It's the equivalence principle.
Sure.
It's the equivalence
No,
principle
equivalence
that
principle is general relativity. That's something different. And
yeah.
that's not
Well, okay, yes, you're right. That's general relativity,
that
right?
that
So
says that there's no difference between what's called gravity in free falling. If you're free falling, but
yes, I know.
that's well, clearly you don't. You just confused. But
No, I do.
but
So
anyways,
you haven't
you're not.
you haven't explained to me anything. Again, the ether does not exist. There is no ether. There is no medium in which electromagnetic radiation is a wave. There isn't.
Let me look. All I'm trying to explain to you is
That's the
there's a guy,
ether,
the guy
dude. That's the
Lorentz.
ether
Let me
theory. The ether
see. I can't
theory.
finish the sentence. Look, all I'm saying. This is a clear way I could say it. The guy Lorentz, he saw Michelson-Morley experiments. He came up with a theory of the aether that explains the experiment. Okay, so citing the Michelson-Morley experiment doesn't make sense because the guy Lorentz, he did all the math and he came. It's called the compensated. I can't pronounce it. Compensation theory of aether, or whatever. You know what I mean? So you're getting confused by citing the Michelson-Morley experiment. That doesn't disprove aether. Lorentz was not an
Yes, it
idiot.
does. Yeah.
Wait. Can I just let me finish the
Yes,
sentence?
it does.
Lorentz came up with Lorentz equations, which you said special relativity uses and all this stuff after Michelson-Morley. Because of Michelson-Morley, he came up with these experiments, but he was still an aether theorist. He was an aether theorist way past special relativity. So the guy was an idiot. You're not. You think you really just told Lorentz, hey, Michelson-Morley, you're wrong. He would be like, what? No, I came up with a whole theory that explains nature theory that explains Michelson-Morley. So just stop citing it. You're confused.
So
Like God.
no, I'm not confused. I'm correct. And actually, Lorentz came up with his theories before the Michelson-Morley. Right?
No.
His theory was in response to Maxwell's equations. Right? You know that, right?
No, I don't think that's true.
Lorenz's theories, right, were a response to Maxwell's equations. Michelson-Morley came about
Nope.
in the early
I
20th
just-
century. Lorentz
I
had
just
his
checked it.
theories. Lorenz's theories date from before that. And he
I just checked it wrong. Nope.
reformulated it after that. He tried to save his theory. Yes, you're right. But he wasn't able
No,
to.
no, you're not. Okay, 18. I just checked.
Okay,
it
so
wrong.
this isn't yes, no, yes, no, yes, no. Can we get some dates?
Yeah,
Can
I
we
was
get
gonna
some dates?
say, yeah,
Can we
1887.
compile a list of dates?
Yeah, 1887, Michelson-Morley experiment. 1892, Lorentz transformations. I don't know what Brenda's just saying. I don't know what she's talking about. Lorentz. That's why special
1892.
relativity.
Yeah.
That's why special relativity. Look, it doesn't even make sense because Lorentz transformations again have to do with time
Okay, why don't
dilation.
you put the dates in the chat and we can compile them? Because if it's part of your argument, if it's important to you,
It's not. The dates aren't important. The important part is that the Michelson-Morley experiments refute the idea of a luminiferous ether, which is the medium, proposed hypothesized medium, that carries electromagnetic waves. There is no medium for EM radiation. It doesn't have a medium. Okay? Are we clear?
I mean,
Light does not have a medium.
that's a claim.
That's physics since Einstein.
I might agree with you, but Fox doesn't. I think he muted himself accidentally and then
He's
left.
gone, and he's back.
Hey, I think you muted yourself or something, because it says you're talking, but maybe you fucked up your mic.
Oh no, I think yeah. Sometimes
Okay, there you go.
does it.
You're
So
audible now.
Fox, light does not really have a medium. It's not the luminiferous ether.
Okay, you have to give us some evidence for that.
It's just physics since Einstein.
Okay, but then what's the evidence for
It's due to the success of relativity and quantum mechanics, right?
quantum mechanics tells us
we know what electromagnetism is. We understand it. We have strong theories about it. Quantum field equations describe electromagnetic radiation very well. We know what it is, and it doesn't have a medium.
Okay, so you're just assuming Einstein was right. But I'm asking you, what's the
No,
evidence for that?
I'm not. My
See, can I
evidence. My
can I finish
evidence.
Can I finish
Okay, go
sentence?
ahead.
Okay. First of all, because I was just discussing, well, because I asked you, why do you think special relativity? You said Michelson-Morley experiments, and well, that's not true. Lorentz and all these people actually were the people who were aetherists, were the ones who explained all the data about Michelson-Morley experiment. So that's not it. Now,
Well,
second point, you said quantum mechanics, which are actually evidence in quantum mechanics that is contradictory with special relativity. I mean, just straightforward.
yes, we know that. Everybody knows that.
Okay, then how would you explain that data? But okay,
Yeah,
since you're so committed to
nobody knows.
Michelson-Morley,
Nobody knows how relativity can be fixed to come into agreement with quantum mechanics. If you have an idea, you should publish.
I'm not. Okay, you're the one who's claiming that special relativity. You're like very confident that the truth is
Yes,
special.
yes, I am, and I'm
Okay,
going on 100 years of global acceptance of relativity, right? In the face of lots of people trying to shoot it down.
okay. I'm gonna ask you one more time, right? What's the evidence for special relativity being true over aether theory, right?
Oh, well,
If you're
that
gonna
would
go,
be the Eddington, the first experiment. There have been plenty, but the Eddington experiment, right?
that's general
That works.
relativity. That's general relativity. We're talking about special relativity, right? I can accept uh general relativity, but reject special relativity. But I'm just saying, what's the evidence for special relativity? Because special relativity is I know you guys were discussing time. For you to hold the B theory of time, you really need special relativity, not general relativity. Um, so what's the evidence for special relativity being
The
true?
Michelson-Morley experiment would be an experimental test, right?
Right, but I already explained to you that the Michael, oh,
You didn't
the
explain
people,
anything. You made claims that were false,
like what? Name me one false claim I made.
right? That because
Well, you claimed
Lorentz,
that the Lorentz transformations and the Michael Morley experiment, you claimed that those were evidence of ether, which that when you say that facts are evidence of something, you are saying that they are pointed to one conclusion over another, which is a truth claim, right?
No,
You
I'm
have to
saying.
substantiate that.
Okay, well, let me put it like this. I'm not sure what you're saying. All I'm saying is this. I'm
You
saying,
what you said that those experiments were evidence for aether theory and
yeah, they are.
not special relativity, right?
No, I never made the second claim. I'll make this claim. All right, let me just. I made this
Well,
claim.
evidence of one thing is not also evidence of a contradictory conclusion, right?
Of course, of course.
correct,
Wait, wait, wait.
correct.
You
I'm not.
can't have something be evidence of two contradictory conclusions. So, how are you substantiating that claim?
Well, what do you mean by they're not
Where can you
negations of each
show in special relativity that it is not the case that these experiments do not validate them, or that they do validate aether theory?
Wait. Slow.
What?
Let me explain to
what
you what. Can I just finish a sentence? Where you let me. You're. Jesus. Look, here's the claim I made. All right. Let me just clarify. Okay. I made this claim. Take the hypothesis. All right. Being aether theory. I said H entails O. Right. So I'm just saying. All I'm saying is this. All right. H entails O. We have evidence for O. Probability of O is high. Therefore, uh, that's confirmation for H being
That's
high.
called
Okay.
affirming the consequent.
No, you don't understand.
If
Prob
if P implies Q, you can't
Yeah,
conclude therefore
you
P.
can't include H. I never said you can include H. I never
Well,
said
that's
that.
what it
See, you're
sounded
confused.
like you were talking
I
about.
said I was talking. I'm saying it's called Bayesian confirmation. I'm not sure. I'm saying that this is how any science works, right? It's induction, right? If you have a theory which entails certain observations, hypothesis entails observations.
Yeah, but it also works by falsification, and the
Okay, we're not
Michelson-Morley experiment falsified the ether
w-
theory.
right. That would imply that hypothesis being aether entails negation, though, right? If aether
No,
theory is true, then
I,
we
if
wouldn't
let
expect
me,
Michael Morley to.
I can put it to you. I can put it to you clearly. If the ether theory was correct, then they would have gotten certain experimental results. They did. This is denying the consequent. So they did not get certain those results. Therefore, the ether theory is refuted. right? It's like if it rains, the sidewalk will be wet. The sidewalk is not wet, therefore it has not rained.
Right, right.
And that's what
That would,
happened. On the ether theory, we expect result A. We did not get A, therefore on the ether theory,
right,
it's been refuted. That's how
right.
it
So
works.
okay. Now, but I'm specifically denying that the aether theory. So I'm saying that that's not true, right? Aether theory does not predict that the one by Lorenz's aether theory does not entail that Michelson-Morley experiment would be false, right?
Yeah, well,
Rather, it
it
actually
does. That
no,
is
no,
what that is. That is what.
slow down.
That's why they did the test. That's why they did it, because they thought they were going to get a discrepancy between different arms of the interferometer, right? Because if you're swimming across the current on one arm and with the current on another arm, you're going to get different results, and they didn't.
Okay, you're not understanding what I'm saying. Oh, look, here's what. All right, if you want me to explain to you, here's what happened. Okay, take this is a most technical way. Take some hypothesis one, including eighth theory, and some other auxiliary hypothesis A. Okay, H and A entailed. I'll agree with you. This the original eighth theory H and A entailed the observation that the opposite of negation of Michelson-Morley experiment observation, whatever, not negation O. It turned out that negation O. It turned out O to be the case. So then we had the option. So all that showed us that either H, being the hypothesis A theory, could be false, or our auxiliary hypothesis have to be false. So one option is to reject the eighth theory itself. Okay, Einstein took that route. What Lorentz did is he adjusted the auxiliary hypothesis, kept aether theory, and explained the math. And he did that before Einstein.
Yeah, but
So then
his
his
theory didn't
revised
check out. His theory hasn't
his
survived.
revised theory. Listen, his revised theory, Lorentz compensatory theory. Lorentz, and it wasn't just Lorentz. Sorry, it was also Fitzgerald. Lorentz and Fitzgerald, they came up with the compensatory theory. So they kept H. They revised the auxiliary hypothesis such that H and A prime entailed O being the Michelson-Morley experiment. Okay, this is just undeniable, right? What?
So how do you
So what I'm
explain the failure to show ether drag?
again,
So
Lorentz.
Ace brought this up a little while ago. He brought up the Sagnac effect. The Sagnac effect refutes the ether. You understand that, right?
No, it doesn't.
Yes, it does.
It's it's the Sanyak. It's not the Sagnac. It's Sanyak.
Yes, it
It's
refutes the
it
ether.
is
though.
a
It refutes the ether.
French.
It refutes the
No,
ether.
it doesn't.
Yes,
No,
it does.
doesn't.
Because that's what
How
the
does
effect
it?
is. It shows that two light
No.
rays are unaffected by the rotation of the device they're in. They're
What
used.
the look? Holy
Yes,
shit! Look,
they're
Brenda,
used.
no,
They're
no, Brenda,
used
Brenda.
in
Wait.
they are
I'll let
used
you finish.
in ships and aircraft today. The Sagnac
Yeah,
effect.
they rely precisely on the fact that a supposed internal frame affects the propagation of light. You said it
Yes,
exactly
yes.
backwards.
No,
Okay, so
it's the rotation of the frame, but not of the hypothesized ether.
well, yeah. So the rotation
Thank you.
of
Yes,
the
thank you.
internal
You're right.
the rotation of the internal frame relative to the galactic frame.
What the fuck are you talking about?
What, you don't understand what a
The
galactic frame is?
frame.
Wait-
What the hell
wait a
is
second,
the
Ace.
galactic frame?
Or the universal frame.
What's the universal frame?
You don't think that there's a universal frame?
What are you talking about?
You don't
The
think that
Sagnac
there's a
effect
universal
is
frame?
an effect that relies on the fact that light is unaffected, the speed of light is unaffected by what direction it's traveling in, and therefore the rotating frame, the device in which it is, you can detect the rotation. It's used as a gyroscope in ships and planes for exactly that reason. If there was an
No, you're
ether,
mistaken.
the Sagnac effect couldn't work.
No, that's
Wait,
one
Ace-
interpretation.
I don't know why you're claiming. I mean, I have a very rudimentary understanding of what you and Brenda are talking about, and even I
Yeah,
know that Brenda's pretty much correct on this. That
on
it's
the
not
Staniak effect?
that the
The Sagnac effect.
it's not the device. It's not the device that's reliable. It's light. Light is
Yes.
reliable.
Yes, it's
What?
reliable. And so what you
Wait,
have
no, no,
is,
no,
is you
no,
have
the
a light-
device has to be. Wait. The device has to be reliable for it to.
The
take
device
the
is reliable because it relies on the fact that that the speed of light doesn't change,
Exactly.
and that its trajectory, the trajectory of light can be altered by the medium that it's in, but not its speed.
Right. So you have like a light source, a beam splitter, and you have light going in two different directions, like in
I
a
mean, this
circle.
is
Yeah,
just
how long?
this
Right.
is
Yeah,
just
we all
exactly how
know-
everybody
we all
knows
know
that
what the
light
Staniak-
works.
Yes.
Yeah, we all know what the Staniak effect is, and the Staniak
Right.
interferometer is.
So I don't know what your contention is, or why you think
Look, I'm
you're
just saying.
refuting it.
Look, I'm just saying that there's like one interpretation that Brenda's gesturing at, but there are other interpretations of the Staniak effect that Brenda may not be aware of.
Okay. What interpretation are you positing, and how is it different?
So again, you can have an interpretation of the Staniak effect relative to a stationary frame, and you have the exact same results. There's no way to distinguish between the two hypotheses.
Okay, can you give me an example of a stationary frame?
Yeah, the universal frame.
Okay, the universal frame is stationary?
Yeah,
I
by
mean,
definition.
you may have to substantiate that.
Okay.
By definition, the universal frame is stationary?
Yeah.
I
It's the frame.
don't-
Yeah, it's the frame.
I
in
don't
which,
see how. I don't see how.
Yeah, it's the frame in which everything in the universe operates in. Like, I don't know what, pretty simple concept.
It's a pretty simple concept that the universe is a stationary frame. No, I don't think it is.
No. I didn't say that. No.
That the universe. Oh, sorry. That the universal frame is stationary. Let me change my.
Yeah.
You phrased it that way. That the universal frame is stationary, not that the universe is a stationary frame.
Yeah.
Okay. So the universal frame is. What are the dimensions of the universal frame?
Well, that's an interesting question. So,
Right.
depends.
Can you define it in
Depends.
terms of its dimension?
Well, it depends on like a lot of stuff. So, like the interpretation of like the cosmic microwave background and that kind of stuff.
So
Right. Does this assume all that we currently know about the universe, or are you going to posit something new as well about the universe?
No, I'm not.
Ace
Well,
feels
wait.
really inferior.
But okay, so look,
Ace?
there's
Ace?
there's data, and then there's
Ace?
interpretation, right?
Because you and I know what the current. Well, we'll just call it the current, right? I'm
the
not
orthodoxy.
saying that this isn't the truth. No, there's no such thing as undisputed truth, right? So
Yeah.
the current conclusion, right, is that the universe is flat,
Or at least
Okay.
nearly so. Yeah.
right? It's not, and the universe is expanding and it's flat, and that there is a finite amount of energy.
Yeah.
Okay. Given those three things, how could you say that the universal frame is stationary?
Well, of course,
It's
that
not.
wouldn't be. Yeah, that wouldn't be
So-
the case under the orthodox interpretation of the data. But I think that some of those interpretations are
Yeah.
certainly.
So I
wrong.
googled this, and here's what it says: there is a universal frame of reference with respect to which
Oh
the
wow.
Just try not to interrupt, please.
Mhm.
There is a universal
Okay.
frame of reference with respect to which the velocity of light in a vacuum is the same in every direction. We call it the universal reference system or the ether, right? The average velocity of light on its way to
Okay, so
and
Ace,
back is
we
for
can-
every observer independent of the direction
Oh wow.
of
So
light
I'm not.
propagation.
Okay,
I'm
no,
not making
Ace,
stuff up? What a fucking
we can boil this down.
surprise.
Ace, we can boil this down in your favor. So all you have to do is, instead of saying the universal frame, you could just say light in a vacuum. That's all you have to say. Because
Yeah, basically.
light in a vacuum's trajectory and speed does not change.
Yeah,
That's
I
correct.
agree with that. Yeah. But still, there's still a very important conceptual distinction between just merely light in a vacuum and quote unquote like capital T the universal frame.
Right, but when you say the universal frame, you're appealing to when you and I just went over what we understand to be the current conclusions about the universe, and then I said, how does that point towards a stationary universal frame, or or the universe frame being stationary, however you want to phrase it, whatever semantics you want to use, okay?
Well, sure, it's a mental
And then you
concept.
appealed to this sort of like mystic soup floating in the air of possible interpretation. You keep
Wait,
resorting
that's-
back to these mystical
No,
possible interpretations that
no,
you
I'm
could
not.
have
No,
that
they're
would
not.
contradict
No.
current conclusions.
No, they're
That is not an argument. That is not an
no.
argument.
Look, they're not mystical. It's just I haven't rendered to you any of these alternate interpretations of the
Well,
I like the mystic soup.
they
thing.
have yet
That's
to be
good. That's really
substantiated.
good.
Mhm. All right.
You've been
Yeah,
okay.
no,
You've
look,
been appealing
Jason,
to
look,
this
Jason, I
soup.
can
You've
definitely
been appealing to the alphabet soup of possible interpretation. Okay, and what I'm saying is that, I mean, myself, I'm only aware of one letter in this alphabet soup, right? And that was what we discussed earlier. So if you see another possible letter in this alphabet soup, I'd like to know, because if you don't think the universe is flat, if you don't
or
think
expanding.
maybe let's say you don't believe in entropy, okay?
No. I do
Just
believe
as
in
an
entropy.
example.
No. Jason, I do believe in entropy. I just have very strong doubts about the notion of an expanding universe.
Okay, that's fine. That's fine. I'm an inverse hollow Earth theorist myself.
I know.
So-
Yeah.
So
Okay.
I don't exactly agree with mainstream interpretations of the universe either, but that's not the point.
Wait, but you okay, look.
That's not the point.
Jason, just man to man
My
here.
beliefs
Just
aren't
man
in
to man here.
question. My beliefs aren't in question, right?
Okay, I know.
We're
Well,
talking
wait,
about-
can I just
No,
clarify?
wait,
Jason,
wait. Ace, I'm almost done. We're talking about your problem,
Yeah.
as you stated. I'm sorry, as Quick Brown Fox stated, that
Mhm.
that aether theory is evidenced by these experiments over anything else.
Oh, okay.
Right,
I'm not
right.
defending whatever Quick Brown Fox is defending.
Wait,
I may
never said
agree.
that.
I may
Never said
agree
Yes, you
with
did.
that.
Yes, you did. Yes, you
Nope,
did.
nope,
Look,
nope,
I
nope,
may
nope,
agree
nope.
with some stuff that Quick is citing, but I have totally different ideas about this stuff than Quick.
All I'm saying is, listen. Here's my claim. All I'm saying is there is no evidence for special relativity over aether theory.
Yes.
Right.
There is. Yes, there is.
No,
just
I would
gave it
agree-
to
I
you,
would agree with
Zemeckis
that.
and
Okay.
Morley.
So
And it's the
and
Sagnac effect that there's a failure to detect the differences, right? The different arms of the interferometer, right? That's the whole point of the experiment, right? We're on the same page.
Okay,
already?
okay.
I don't
What
think
I
any
wanna-
of us thought that.
What I want to know is, we're going down a rabbit hole. Ace, can you tell me what you were gonna say? I was trying to finish, but you were trying to
Okay.
interrupt me.
Yeah,
What were you
yeah,
gonna say
okay,
about your
so-
possible interpretations?
Yeah. Okay, so like in particular, like around the expanding universe hypothesis, right? So that came about from Hubble's observation of redshift, and the redshift was interpreted as essentially. Well, first it came from Hubble's observation of blue shift of the Andromeda galaxy, ironically enough, but redshift has been interpreted as evidence that the universe is expanding because stars that are supposed to be more distant are more strongly redshifted.
Right.
The problem with this is what's known as redshift quantization. So the thing is that it's an empirical fact that redshift does not actually have a continuous distribution amongst the galaxy. Like actually, that redshift occurs in quantized units, and this would suggest that the interpretation of redshift as movement away from the observer is likely mistaken. Just look up redshift quantization.
Okay.
What do you
So
quantize unit?
without me looking it up, are you saying that there is some kind of force that, when the force is different, that redshift is different? Are you appealing to another force? Is this a quantum force?
No. It has
No?
nothing. No. I don't think it has anything to do with quantum mechanics at all. Actually, I actually think that it has to do with the interaction of light with.
Quantized redshift is what you're talking about.
Yeah. Well, redshift quantization.
What that means is that redshifts of distant objects tend to cluster around certain discrete values.
Yeah, and that's a really big problem for people who are interpreting redshift as
There is an
relative.
unknown mechanism for redshift. Okay.
Yeah.
Referred to as intrinsic redshift or non-cosmological redshift. I mean, see, this is right, but this is a hypothesis. This is
No. This has been observed. This is an
right
observation.
and right.
Right, it's observed, but the explanation
There's an
is-
observed phenomenon, and then we
Yeah.
named a hypothesis to explain it.
Yeah,
Right.
that's
Well,
correct.
no.
That's correct. Yes,
Wait.
that's
Naming
correct.
something's not an explanation, though.
No, we named a hypothesis, right? And the hypothesis is meant to explain the observation. The observation.
What's the
People
explanation?
are wrong about their observations all the time.
Maybe. But what's the explanation, though? Because I mean, I have my own pet explanation of redshift quantization.
Right, you understand it better than I do. I don't know anything about relative. This is okay. So it's not relative redshift. It's intrinsic redshift. Which I mean, I really don't understand, but I'll have to look into it more. But what I'm saying is,
it's intrinsic. They're claiming that it's intrinsic to the light source, which I
Right.
think is mistaken.
okay, you think it's mistaken. So the hypothesis is wrong, but the observation. But they did observe what they're trying to explain. Is that what you're saying?
No. They observed it. It contradicts their theory, so they're just saying, "Well, this is just another contradiction we have to explain." It's a hole in the theory, essentially. So, my understanding of redshift quantization is that it's purely an electromagnetic phenomenon. So it's actually well known that in the laboratory you can actually redshift light by passing it through very strong plasma fields.
Yeah,
And so
actually, if you look
I think
at
that's
the,
exactly what's happening in space.
if you look at the Wikipedia page for redshift quantization to the modern discourse section, it seems like there isn't really strong observational evidence for this. It seems to be problematic whether it even exists.
Yeah,
That's what
maybe,
that
but I'm
that entire
from
section
what I
lays out that there's a survey of 46,000 quasars, right? They discovered 6 peaks, but they conclude that the correlation is unlikely to be a selection effect. There's several.
The redshifts of over
so it's
250
unlikely-
galaxies.
Yeah, so it's unlikely
Galaxies,
to be a selection effect.
The formal confidence levels associated with the results of the observation of 250 galaxies are extremely high. So there's very little doubt, right? There's
Yeah.
very little doubt that what they're observing is not what you're claiming.
Wait, I'm confused by that. What do you mean?
Okay. So far, the redshifts of over 250 this was 1997, Guthrie and Napier.
Yeah.
So far, the redshifts of over 200. This is just from the Wikipedia page.
Yeah, I'll have to
The
pull it up.
redshifts of over 250 galaxies with high precision HI profiles have been used in the study. In consistently selected subsamples of the datasets of sufficient precision examined so far, this is in 1997, so I don't know what they
Just
about
scroll
these
down.
galaxies in the
Scroll
future, but
down.
the redshift distribution has been found to be so strongly quantized in the galactocentric frame of reference. The formal confidence levels associated with the results are extremely high. But
Yeah,
there is
scroll down.
no evidence after this. There's no research
Yeah,
there's
so in
no
2000,
research
Yeah, there is
wait,
evidence.
So
There
here
is
it says
experimental observation
2007
afterwards.
analysis
There
of
is.
quasars by Ryabinov observed a pattern of statistically significant alternating peaks and diffs in the redshift ranges between 0 and 3.7, though they noted no statistical correlation between their findings and the
Carlson's formula, right?
Okay.
Which would, if they found no correlation between their findings and Carlson's formula, which
Oh,
I
I'm not
understand.
advocating. I'm not advocating for Carlson's formula, though.
That's fine, but essentially what you're doing is you're positing a third possibility.
Well, he thinks he's a physicist.
No, I'm a hobbyist.
Yeah.
Okay,
I'm
okay,
I'm just saying.
so
I'm just saying that I have a.
are you
pretty
positing a
good-
third hypothesis?
I already explained what I think it is. So, like I said, in the laboratory, we can cause redshifting of light by passing light through very strong plasma field. This is like a repeatable experiment, and so I think that that's actually what it is. That plasma fields in deep space are causing quantized redshift.
Okay,
And I
let's
think that
right. I don't know enough about this to
yeah.
contradict you. So let's start from your assumption that this is quantized redshift, right?
Mhm.
How does that change what we understand to be? How does that change, in your opinion, what we understand to be the expanding flat universe?
Right, exactly. So so if plasma fields can cause redshift, then that puts into question the interpretation of redshift as relative movement.
Right, but it doesn't refute it. So if there are special cases where these plasma fields can change redshift, that doesn't.
It's not very special. It's actually pretty common.
Okay, that's fine, but is it in every case? Are you positing that that quantized redshift is every case of redshift? Can you make that claim?
I wouldn't put it that strongly. I'm just saying what I would say is that this puts a real big question mark.
Because what Hubble was observing was a trend within within redshifted galaxies.
Yeah, I'm just saying this puts a really big question mark on the interpretation of redshift as relative movement. And plus, there's a really good book about this called the Atlas of oh gosh, what's it called? Let me see if I can look at it. It's like the Atlas of unexpected galaxies or something. It's a really interesting book that actually talks about the problems with like this interpretation. So there's like really good examples of specific galaxies where like part of the galaxy is strongly redshifted and part of the galaxy is strongly blue shifted. So it's like it's this one galaxy and one part of it is redshifted and one part of it is blue shifted. And so like are we supposed to think that like part of the this one galaxy is flying towards us and the other one's flying away? Like,
is this part of your electric universe theory, Ace?
No, I don't hold to the electric universe.
Well, I'm getting the distinct crackpot vibe here.
Well, I think you probably think the majority of things I say are crackpot, even though I have like probably a much better grasp of physics than you do, Brenda.
Well, I've basically refuted everything you've said in the past.
Okay,
year or
look,
so.
go ahead and argue why the stuff that I sent you earlier with Ron is wrong. I doubt you can.
So
come on.
I'm just asking if this is part.
All you did was appeal to the experts, appeal to consensus.
Yes, I'm asking if this redshift plasma thing, because plasmoids are a typical thing that the Thunderbolts Project people and plasma people kind of put up as one of their beliefs.
Yeah, and plasmoids are real. We've made them in the laboratory.
Yes, of course they are, but they're not. Yeah. They're not.
Oh, you don't think that they happen in space?
No, that's
really?
Not what
Why?
I'm saying. I'm saying that they're not a factor in what you're trying to say.
I'm not talking about plasmoids, though. Plasmoids are a particular configuration of plasma. I was just talking about general plasma fields. Come on, Brenda, keep up.
There's lightning in space.
There is. I agree.
Right. But I don't know of any evidence of lightning in space that occurs without an atmosphere.
In what?
So this
without an atmosphere.
Yeah, this is part of a crackpot theory called plasma universe.
Occurring in space without an atmosphere.
Well, no, it's a well-known fact, and it's been observed that there are intergalactic Birkeland currents. That's just a fact. And those would be considered thunder like space
Intergalactic Birkeland current.
Yeah.
Yeah. There's
So
no such
constant
thing.
currents? Are those constant currents?
Yeah, they're wound current pairs actually. So they form like almost like a DNA structure where they're kind of wound one around the other.
What are they called? Did I look it up?
Yeah, just look up Birkeland current.
Birkeland current. It says Birkeland currents only apply to Earth.
That's welcome
The,
to ACE.
the Wikipedia page says a Birkeland current is a set of currents that flow along geomagnetic field lines connecting the Earth's magnetosphere to the ionosphere.
But cosmology, but plasma.
Yeah, but
plasma.
they've also been observed in space, so.
But plasma.
You said that there were Birkeland currents connecting galaxies.
Yeah.
And
there
what
aren't
I want to know,
Yeah,
what
there
I
have been
want to know is,
observations- yeah, there have been observations of filamentary structures that some researchers have interpreted as intergalactic Birkeland
Those are
currents.
internet crackpots.
okay,
think
so
that.
like I said, my understanding was that these kinds of current that are not explanatory in terms of because you can explain lightning without even needing to know about Birkeland currents. But the
Yeah,
point is
I
that
agree.
my understanding was that lightning only occurs within an atmosphere. And you said, well, there are intergalactic Birkeland currents. And what I'm wondering is,
Mhm.
what did you mean by intergalactic Birkeland currents? Because the Birkeland current is only describing Earth's ionosphere. So do you mean, is there another name for it? Did you
Here, one
see
sec.
it somewhere
I'll look it
else?
up. I'll look it up for you. One sec.
All right, so this is typical ACE. He just puts forward a lot of these crackpot theories. He's got crackpot theories for the pyramids and for all kinds of things.
I mean, he definitely seems like an information encyclopedia, but what I'm wondering is, where does it all connect?
It doesn't, and it's all
Oh,
bad
okay.
information.
No, it definitely connects. I actually have a really coherent and all-encompassing theory of the universe. It's just that most people won't actually sit down and like talk with me about this stuff because
Yeah,
of
because you're a
people.
clown. You are, Ace. You're a
Intergalactic,
clown. Everybody laughs at you.
electric.
You literally make
That's
shit
how-
up out of thin air, Ace, just to
What's
sound
what's
like
one
you're
thing that I've
important.
made up? What's one thing that I've made up?
We
Name
caught
it.
you already in this past Birkeland
Like what?
intergalactic
Like what?
Birkeland occurrence. That's one thing you just pulled out.
How is that?
Okay,
made
okay, okay, wait.
I
Wait,
named that up,
Ace.
even though it was named after a
Ace, Brenda.
scientist.
Brenda, you need to hear about this. This is Google. I'll screenshot this. I looked up intergalactic electric currents, and Google provided me with an explanation. Google says intergalactic electric currents are only proposed by electric universe theorists and have been largely debunked.
Yeah, that's what I've said
Right.
before. He's
So
using
what I'm saying is
Thunderbolts.
that
Yes,
Ace,
Thunderbolts
Ace,
project.
How have they been?
Yeah.
Wait. What's the debunking? Where is the debunking? Just
that's what Google just told me. Google
I
just
get Google. Right. I get Google's like become the new Ministry of Truth.
Exactly. I don't necessarily trust that, but what I'm wondering is, I'd like to know where and how you got the
we call
information.
Google the Oracle of Delphi.
Exactly,
Yeah,
exactly.
right,
So
Yeah.
where
Okay,
exactly
so-
did you get information about intergalactic electric current?
I've spent years and years studying physics. It's just
Okay.
you kind of run into you know just like quantized redshift. You kind of run
Right.
into this stuff after a while.
Right.
So like okay, so actually I'm looking at the Wikipedia article, right? So you understand that for every current you need a source and a drain, right?
Right.
Okay.
A
So-
positive and a negative.
Right. And so looking at the Wikipedia article, you can see very clearly that these currents go off the edge of the picture, right? So where are they flowing from and to is the question.
No, that upward flow that you're seeing is
Mhm.
Earth's upper atmosphere, which extends way beyond the picture.
I know, but where's the source though?
The source is I mean, it says right here in the article. It says that the corpuscles, or however you fucking say that word,
Yeah, corpuscle.
corpuscles of electric current are generated by solar wind that enters Earth's magnetic field. So
That seems really
Yeah.
strange.
What do you mean
well,
that's
we
strange?
already know. We actually already know that Earth's atmosphere is a filter for solar wind, and that creates electricity. We already know that.
Yeah.
So
That's all you need is a magnetic field and moving
I
electric
know that a
charges.
lot of crazy people say, "Oh, X is solar wind," and that solar winds explains everything. But it looks like that is how Birkeland substantiated it, was that it is generated by solar wind.
Yeah. Get wrecked,
So-
Ace. Get wrecked.
And that Birkeland currents are explanatory for
Sorry,
the
I'm only-
aurora.
I'm only-
It says
wait, I'm
it
only
also
half
says here
listening.
that
Sorry, I'm
the
sorry.
aurora is explained by Birkeland current, and those are the aurora is created, we know, by solar wind. So
yeah, highly energized charged particles meeting the Earth's
Right.
magnetic field. Yep.
right, and
Okay, so here's an archive link. So a search for warm hot gas filaments between pairs of luminous red galaxies.
okay,
And they actually do talk about because I don't just read I fucking love science and think
warm
that's
hot
the
gas filaments between pairs of luminous red.
yeah, like I actually read like primary sources for this kind of stuff.
No,
And-
I'm not refuting you with Wikipedia.
No,
What
no,
I'm
no,
just
no, no.
saying is,
No,
is that
that's more
how
of a
do you
jab. That's more of a
reconcile?
jab at Brenda. That's more of a jab at Brenda. Than
Okay, what I'm attempting to do is reconcile what I know with what you're telling me. Like I don't know a lot about this stuff. I'm using Wikipedia sort of like as a general, oh, well,
Yeah.
I knew that, but I didn't know that. Oh, but I knew
Yeah.
that, but I didn't know that.
Well, look, Wikipedia is going to always be a lagging indicator of the state of the art.
I don't necessarily trust Wikipedia, but if
No. But look. Do you know what I mean by lagging indicator?
I have a
That it-
general understanding of
Yeah.
I have a general understanding of quanta and of electricity.
Yeah.
Um,
Yeah, actually, I'd like to
so-
actually listening to what Quick was talking about earlier. I'd actually really enjoy having a discussion with Quick at some point if you're interested, Quick, because I think you probably have some really interesting ideas.
About what?
Well, Quick was mostly just saying no all night.
Yeah, that's
No.
all he
Just
said.
about the whole
He just said
ether
no.
theory and that kind of
He
stuff.
Yeah,
didn't have
I
anything
mean-
of substance at all.
That's kind of true.
He-
Right. Except for
No,
the part
actually,
where
wait. I think Quick. Go ahead, Quick.
It was
Go ahead.
completely devoid of any substance. He could
All
barely
right,
string
right.
together a sentence.
Right. Except for the part where I explained Lorentz transformations, aether
Yes.
theory, special relativity.
Exactly.
You know, you literally didn't know what special relativity is. You literally brought up the equivalence principle. It's really ironic what you're talking about here.
Yeah.
So I don't know what you mean. I literally, here's what you made this claim. Michelson Morley shows
Yes.
aether theory is wrong.
It does.
I said no.
Yes, it does.
Lorentz transformations. What are you talking about? That you can use Lorentz transformations with aether theory, right? That's
Yeah. Exactly.
what Aether and Fitzgerald did. So
Yeah.
that's not evidence against aether theory. Then you reply
But
with
there is
blah.
no ether.
No,
There is no ether, and we
How do you
proved
know
it.
that, Brenda?
Right.
There's been
You have to
multiple
use the evidence for
experiments.
that.
Oh
You
yeah,
can show it.
one experiment from the 1800s just proved a fucking
No,
concept.
that's a straw man. There have been
Okay, so what
multiple
about
experiments.
What about the Mount Wilson experiments, Brenda? That actually did detect a moving ether.
I don't know what that is, but
Oh, you don't? Oh, you're completely ignorant. What a surprise!
no, yeah, but why do you think that an ether exists?
I'm not saying that I know for a fact that the ether exists. I'm just saying that there's
You
contradictory.
just cited an experiment that you
Yeah,
think
look, I'm just
shows an
saying that
ether
there
exists.
was observations.
So-
there's
so show
observations
me
at the Mount Wilson Observatory.
Show it to me then.
Yeah, well, just look it up. Mount Wilson Observatory interferometer.
Well, you
Actually,
understand
there was
it.
a
You
much
brought it
more
up. You explain it
extensive-
to me. Go ahead, explain it to me.
Yeah, there.
I'm
Okay,
listening. I'm listening.
so the Michelson-Morley experiment was actually a very short-lived experiment that had very, very lax controls over their experiment.
Dude,
the
it's
Mount
something
Wilson,
high school.
the
it's-
Mount
that's
Wilson
something that's
experiment.
done in
One sec, I
undergraduate
was in the middle. I was
physics
in the middle of
today.
something. So, like, you're asking me to explain something, and I'd appreciate if I could finish. The Mount Wilson experiment was a prolonged experiment over multiple years with much more strict controls on their apparatus. And they actually observed a change in the observed ether wind relative to sidereal time.
Yeah, I don't
Like-
know what you just say that, but I don't know what you're talking about. And there have been multiple.
Okay, I'll
hundreds of
look it up for you.
experiments.
I'll spoon
Yes.
feed you, baby. I'll spoon
Well, yeah,
feed you,
you need
baby.
to. No, you need
Zoom,
to
it's
back up
the
your
airplane's coming
claims.
in. Open up.
Yeah, you need to back up your claims, right? And there
Yeah,
have
I
been,
am. I'm going to
you know,
right now.
undergraduates do the Michelson-Morley experiment today. People can do that, and there have been
Ace.
other experiments too.
Yeah, and you know,
What are you,
there
wait,
is-
wait, wait,
there
what are you
is
talking
no
about? You can
ether.
only do those. You can only do that experiment when like Venus is like in transit. You can't just do that anytime. They don't do
No,
that
that's a different
today.
experiment. You're talking about
Right.
that's gravitational lensing. This
Uh,
experiment showed that the speed of light is constant.
Are you talking about when they have the story? Yeah, but I still think there's only like a few times in a year because I remember like the efforts they had to take to make sure that it was done at a precise time because it only happens so many years or so many maybe every decade. You
That's
can't just do. I'm not just talking about the Venus. I'm talking about I can double check, but I'm pretty sure like it's not something you can just do whenever you want to.
well. Well, let's be clear. Michelson-Morley experiment showed that the
It
speed of
has to
light
be
is
when there's a
constant.
solar. I remember. I'm sorry. No. It's you have to have a solar eclipse in order for it to happen.
Right. That's general relativity. So the one Brenda's talking about is the experiment that showed that the speed of light is constant. Supposedly showed that, right? So that one it's not too difficult. There's ways of you just shoot like a laser and whatever. You have a bunch of ways of like measuring the speed, given a certain. The one you're
Well,
talking about, yeah,
you
is
send it in two different
gravitational lensing.
directions, is what you do, and compare.
Okay, sure. The point
Yeah,
is
that's the Michelson-Morley experiment. Do you not know it?
off the top of my head, I don't know the exact detail. I
You
just
don't know
know
what the Michelson-Morley experiment is?
no, I know what it is. I know what it showed. If you're
Well,
saying,
what?
do I
No,
know
but what is it? What
the
is it
procedure?
physically? No, I
If
want
you're
you to
asking the
answer. I want you to answer this.
That's
You've
a
led me
cross-beam
down this
interferometer.
trail
Fox.
for
Fox,
an hour.
you've been saying
Tell
all
me what it
night.
is.
You've been saying all night that the fucking Michael Morrison experiment does not help Brenda's case. If you don't know what it
Right.
is, then you're being exposed, right?
Yeah.
Okay, so can I just answer that question? But what do you guys mean by that? Let me just be clear. Mike, I know what the conclusion of what the officer the what it showed. If you guys are saying like, do I know the
I want you
procedure
to
by
tell
which?
me what the actual experimental setup was. What
Right.
they did.
Yeah, I don't. Yeah, if you're saying I
You
don't know that, I
don't
mean I don't know.
know. You
No, do you
don't
know it?
fucking know?
No, off the top of my head, I
It's
can't.
a cross-beam interferometer.
Yes, you don't even know what it is. And
Well,
you've
I
been
don't know what.
spent you've spent this whole time bloviating, and you
Why
don't
would that
know what it
matter?
is. You
No, I
don't know
why
what it
why would it
is.
matter? Why would it matter?
no. Why would it
Oh
matter?
fuck. Oh fuck. Count with
Wait,
your
why would
pants
that matter?
down.
Holy
Count with
shit.
your pants down. Dude. Quick.
Whatever.
You're not so quick, Mr. Fox. You're not
Wow.
so quick.
Just wow.
Okay.